Okay, hello everybody. We're gonna look at worksheet 13.1 in this video. So write your name and your class, and then we'll start with the introduction of solving simple inequalities. Okay, so introduction. Inequalities are mathematical expressions involving the symbols, okay, these four symbols over here, and you need to know what they mean and what they represent. Okay, so in our daily life, the relationship between two quantities may not be an equation but an inequality. Suppose the ages of Tom and his father are x years old and y years old respectively. Since x must be less than y, then we represent it in this form to say that x less than y is an inequality. Okay, so how do you remember which one is the more than symbol and which one is the less than symbol? I generally like to use the Pac-Man analogy. Okay, so this is your Pac-Man. Okay, and your Pac-Man likes to eat the larger number. Okay, so you can see that the mouth, okay, is always facing the larger number. Right, so if you look at this summary table over here, this is the one that's important and you need to memorize this because you need to know what the inequality signs mean. Okay, so in this case here, this is x is less than 8. Okay, and then with a dash across, okay, that means less than or equal to. Okay, you can take the dash across as part of the equal sign. Okay, so what this actually means is that x is less than 8 and x is equals to 8. So these are two possibilities. Sorry, not and, I mean or. Okay, and then the same applies for the more than 8, x more than 8 and x more than or equals to 8. Okay, so you need to know what these four inequalities represent, what the four symbols represent. Okay, let's take a look at the let's try question. Use an inequality to represent relationship involving the given variable in each of the following statements. So the expenditure capital Z dollars per person at a shop must be must be $50 or more. So step 1, read the question and identify a variable. The variable is Z. I'm just going to emphasize here that since the question gave us capital Z, we're going to do the same thing over here. So identify the appropriate sign. Well, we see $50 or more, right? So it can be equals to $50 or more than $50, and therefore it should not just be the more than sign, it should be the more than or equals to symbol. And then with that, we just fill in the inequality respectively. Okay, if this were a question, in an inequality, in our final answer, we will not have the units, so we will just leave it as Z is more than 50. Okay, so let's try question 2. The pH value X of a face cleansing agent is less than 7. So in this case, 7 is not less than 7, so we do not include the equal sign at the bottom. Therefore, we will just have X is less than 7 with no equal sign or no dash at the bottom of the less than symbol. And question 3, the height h centimeters of a basketball player is at least 190 centimeter. So you know that it has to be more than 190 centimeters. And the question now is whether we will include the dash at the bottom. The simple question that you should ask yourself is this: is 190 at least 190? Yes, it is. So we will include the dash at the bottom. Okay, so let's move on to the next page. Try the mastery practice questions yourself. Put a pause on the video, and then once you're done, play the video to check through your answers. Okay, so let's look at question 1. The number of passengers N of a taxi should not exceed 4. So N is less than 4. Do I put the dash to indicate equals? Well, is 4 less than or equals to, does 4 not exceed 4? It doesn't. So you do include the dash. Okay, so N is less than or equals to 4. Now, question 2. Y is greater than 89. Is 89 greater than 89? No, it is not. Okay, so you do not include the dash in this case. And finally, for question 3, the volume V of juice in a can is at least 375 centimeter cube. So here you have V is at least or greater than 375. Is 375 at least 375? Yes, it is. So you'll put a dash at the bottom, and these are your answers for the mastery practice. Okay, let's move on to the activity-based learning. Okay, fill in each blank with an inequality sign, more than or less than. Okay, so try out this activity-based learning first. Put a pause on the video. Once you're ready, play the video to see your answers. Okay, so these are quite simple. I'm just gonna do some very quick working. Okay, and then you should be able to check that your answer is correct. Sorry, this is not a more than, this should be a less than. Okay, and then for this one here in part B, -5 times 3 is -15, -1 times 3 is -3, and this should also be a less than. Right? So now what I want you to observe here, we started off with a less than symbol. Did we change the symbol? No, we didn't. Okay, again here, there is no change. Okay, so multiplication, we are multiplying both sides by a positive values by a positive value will lead to no change in the sign. Let's look at the next case. Okay, given that 6 is less than 12. Now let's fill in for part A. This is equals to -12. This is equals to -24. In this case, -12 is more than -24. In part B, you have on the left is 10 and on the right is 20, and 10 is less than 20. Now observe that even though we are given 6 is less than 12, the sign does change. Okay, given -2 is more than -4, the sign does change again when we multiply both sides by a negative number in this case. Oops. Okay, by a negative value in this case. Alright, so, well, these are some of the observations that you can make, and let's generalize this observation to the scenario where we have A is less than B. Alright, so when we multiply both sides of the inequality with a positive number, say 3, what will happen to the inequality sign? As mentioned above, there will be no change, and so we can indicate that 3A is less than 3B. Okay, and if we multiply this with a negative number, say -3, then there will be a change in the inequality sign. So we will expect to get the inequality -3A is now more than -3B. Okay, let's move on to the next page. So this is where we get a bit more slightly more challenging questions, but it is actually very similar to solving equations. Okay, the solutions of inequalities can be compared with the solving of equations. Okay, so let's look at solving 3x equals to 9 first. Well, basically in this case, you will just divide by 3 in both sides. Right? So if we have now 3x is less than 9, we are making x the subject, and then we will divide by 3 to get x is less than 3. And in this case, well, notice that there is actually more than one solution, right? Because there are a few numbers that can satisfy x is less than 3, right? For example, x equals to 1 or x equals to 2. But does it mean that those are the only cases? No, they're not. Alright, it can be any number less than 3. So you're also thinking about x equals to 1.5. Maybe you have 0. It could even be negative numbers like -3, so on and so forth. Alright, so you are looking at a range of numbers, not just two possible answers. Whereas in an algebraic equation, you only have one solution. Alright, so that's the main difference between an inequality and an equation. Okay, so let's look at the number line representation. Okay, in this case, if you want to draw x is less than 3, then you must draw a hollow circle to indicate that the number 3 is not included. Okay, so this is the hollow circle that I'm referring to. Okay, so draw your number line as per normal. Ruler and pencil with equal spacings apart for the integers, and because it is less than 3, then you draw an arrow to the left of 3, because you're looking for all the possible numbers from 3 onwards and less than 3. So 2, 1, 0, so on and so forth. Okay, whereas now if we were to look at 3x is less than or equals to 9, and then if you were to solve it, you get x is less than or equals to 3, it means your solution is now inclusive of number 3, because x equals to 3 gives you 3 times 3, it is equals to 9, and 9 is less than or equals to 9. So in this case, you must give a solid circle to indicate that the number 3 is included. Okay, so you need to shade the circle, and everything else remains the same as the number line representation above. Okay, so with these examples, go on and try the mastery practice. Make sure you use a ruler and a pencil to draw the number line, and be reminded to indicate equal spacing apart when you draw your integers. Okay, so press a pause, and then try it out, and once you're ready, press play. Okay, so at this point, you should be just checking your answers. So this will be my number line. Okay, so I have my 0 here, 1, and then 2, and x is less than 2, so there is 2 is not included. That's why it's a hollow circle. Okay, drawn above 2, and then that's it. This is my answer. Okay, so for question 2 now, number line, again indicate my 0, indicate where negative 1 is, negative 4 over 7 is slightly in between. Alright, and then now I want more than, and I include negative 4 over 7, so let's draw the solid dot first, and then a line to the right, an arrow to the right, sorry. Okay, so these are my 2 answers for the mastery practice. Okay, let's move on to the next page. Okay, so here are some tips for solving inequalities. Let's look at the first one. Okay, when we add or subtract the same number of both sides, here in this case, sign remains the same. Okay, if we were to shift sides and changing the orientation of the inequality sign, again, I'm going to use a different highlighter. Here the sign changed. Okay, because essentially we are switching the left hand side to the right hand side. Let me just demonstrate what the second one means. The first one is quite obvious. If I were just to add 3 on both sides here, then, well, there's no change to the inequality sign. Same thing if I were to subtract 10, there should be no change. Whereas for the second one, if I were to have, say for example, starting out writing 2 is less than 3, then if I want to change the left hand side to the right hand side and vice versa, then I am basically writing 3 is greater than 2, right? So in this case, the inequality sign changes. Okay, so the next one, okay, when we multiply or divide by the same positive number, okay, take note, positive number, the sign remains the same. Okay, so here we multiply by half, and there is no change in the signs. Okay, when we multiply or divide by a negative number, then what you should notice is that the sign does change, right? So here notice that the sign has changed, and then it stays the same after that. Alright, if I may demonstrate this in another way, if you have 2 again is less than 3, then multiplying by -1 to both sides, okay, you will have -2 and -3, and now -2 is actually greater than 3. So again, you can see that the sign has changed. Okay, similarly, sign change. Okay, so sign change when we divide negative numbers or when we multiply negative numbers. Okay, let's move on to the let's try. So here in question 1, okay, represent the solutions of each of the following inequalities on a number line. So you have negative 3x is more than 15. To get x, we need to divide by -3 on both sides. So let me just write that down at the side here for you to keep track. Okay, so dividing by -3, that means that we need to change the sign, and 15 divided by -3 gives me -5. Okay, so now we need to draw our number line. Okay, so we're gonna have -5, -4, -3, -2, -1, 0, and then it's an open hollow circle because there is no equal sign, and then it's to the left. Okay, please make sure that you do your drawing, when you draw your number line, it is in pencil and using a ruler. Okay, let's look at question 2. 1 minus 2x is less than 6. Alright, so now we're gonna want to make x the subject basically. So I need to subtract 1 on both sides. So subtracting 1 on both sides, that does not change the sign. So I have minus 2x is less than 5. Okay, and then I'm gonna divide by -2 on both sides. Okay, so it's a good habit at the start to write down all these workings to remind yourself whether you need to change the sign or not. Okay, and then here you have x is less than, well, it's no longer less than because you need to change the sign. So x is now more than -5/2. Alright, and then draw the number line. So don't forget to include your 0. -5/2 is to the left. Oh wait, sorry. No, you don't have to draw the number line in this case because the question did not ask you to do so. Alright, so let's look at part B now. X plus 1 is more than or equals to 3/4. You want to make x the subject, so you're going to subtract -1 on both sides. So this one means that you do not need to change the inequality sign. So 3/4 minus 1. Okay, if you can't do this mentally, press your calculator. You will end up with x is greater than -1/4 as your final answer. Okay, so now let's move on to the next page. And again, try out the mastery practice yourself first before looking at my solutions. So press pause on the video. Once you're ready, press play. Alright, so question 1. This will be the number line that we are looking at. So x is greater than -6. So definitely you need a -6, -5, -4, -3, -2, -1, and 0. Hollow circle because there is no equal sign. Okay, it's just a more than sign, and then to the right. That's it. Okay, let's solve the following inequality for question 2. So 1 minus half x is greater than -1/3 x. Let's make all the x's on the left hand side, shift them all there. Alright, like how we solve it in an equation. So in this case, we're gonna add 1/3 x to both sides. And I'm gonna do this step by step. Of course, if you can do it faster, you wanna maybe subtract 1 at the same time. But since this is the first time that we're doing it, I'm gonna do it slowly. So this means we're adding 1/3 x. Remember that when we add something, there is no need to change the sign. So more than still remains as more than. Again, minus half x plus 1/3 x. This gives us 1 minus 1/6x greater than 0. Now we're going to shift -1 to the right side. So minus 1 on both sides. And again, adding or subtracting a number does not change the sign. And then finally, well, we want to get rid of this negative 1 over 6. So the only way to do that is to multiply by negative 6. And now, because we multiply by a negative number, we have to remember to change the sign. So x will be less than negative 1 times negative 6. This gives us positive 6. So the final answer is x less than negative 6. X less than 6. Okay, let's look at question 3. Slightly different from what we've been used to, but no difference as long as you understand the concept of inequality. So given that x is less than 11, find largest values of x. Okay, they need to specify largest value because otherwise you can have more than one possible answer. Right? Remember that x less than 11 is a range of answers. So the largest value makes it sure that we are only giving one answer. Okay, so let's just take this down. One solution for each part. Okay, such that x is so on and so forth. Okay, you can follow the hint here and draw a number line. But I think in this case it's quite basic in the sense that x less than 11, you're looking at numbers less than 11. Alright, nothing too difficult about that. So what's the largest possible even number? Well, you're just looking at the number 10. Okay, perfect cube, that should be 8. And this is what you get from 2 cube. Prime number, you can't pick 11 because 11 is not smaller than 11. Okay, let me just use a different color to... Okay, you can't pick 11. So the smaller prime, the next largest prime would actually be 7. Okay, largest value of x where it is an integer, that's got to be 10. It cannot be 11 again. And perfect square, well, that is 9 from 3 square. Okay, so move on. Try out the what's wrong yourself. This is something that your teacher will be going through with you in class. So get your teacher to do that, and then do the homework, and the teacher will also go through the solutions or any problems that you may have with the homework in your next lesson. Alright, don't forget to complete my reflections, and you can leave the Futoshiki section to when your teacher wants to whether your teacher wants to go through it in class or not. Alright, so with that, I've come to the end of this worksheet 13.1.